what are the operations that we can perform on the linked list? So we are going to discuss about the different operations that we are going to perform on the linked list. So we can perform many operations. So in this video, we will discuss about only the traversing a linked list. So we can do the traversing on a linked list. What's called traversing? Traversing means accessing each node exactly once. Exactly once is called a traversing. And while traversing, what we can do, we can apply some process. Process may be printing the values on the screen, or maybe doing some arithmetic operations. Any operations that you wanted to do, you can do it here. That's called a traversing. So and also what we can do another operation called searching. Then also you can do deleting, and even you can do inserting. So these are the different operations that we can perform on the linked list. There are different types of linked lists that we can discuss later. So these are the operations. First, let us talk about traversing a linked list. So traversing a linked list means accessing each node exactly once. So this is a linked list. You can see that here. So here you have a linked list. There are some nodes are there. How many nodes are there? Just it's an example. 1, 2, 3, 4 nodes are there. Where do we start from? We start from 2. And after that, it will be going to the third node and so on subsequently. So we have to access each node exactly once. While you access, you have informations on the node, and also you have the link address. We are bothered about the information. Information is nothing but our data. What are the data that we store on the linked list? So we need to have those information to the access to that particular data only. Okay, fine. So for doing the traversing operation, we follow one simple algorithm here. So the algorithm, it is basically the function of list, PTR, and process. List means the linked list, or the linked list that we are going to give. And PTR is the pointer pointing the linked list. And also what do we have? A process. It can be anything. Any process could be applied, as I discussed earlier. So what do we do first? First we set PTR is equal to start. PTR is equal to start. You may ask, what is the start? The start is a variable which points to the very first node on the list. First node on the list. Or it depends. We can configure it to any node. That also you can do by that, because the start only important. Start only, it says that from where we are going to start. If we are going to start from one, but probably the third node, then the next node will be 4. And if you're going to terminate, it will go into terminate at that. Or if you're going to start from the first node also, then you can go to 1, 2, 3, 4, and all these things can continue to go on. So the start is very important. So what do? We set the PTR, the pointer for each node. We'll assign it to the start. So we initialize the PTR with the start here. Okay. Next, what do? We repeat the following steps until we have the PTR not equal to null. That means what? PTR will be pointing to every node. So probably let us say this is one address, 1, 2, 3, 4 is there, right? Link address. Here we have a link address. At one point, if it's good, this is going to be terminating node, it's going to be null. Okay. So if PTR is equal to null, it means to say that we have reached the end of the list. Okay. So that is why we have to do the operation continuously until the PTR is not equal to null. When it's equal to null, we are going to terminate the operation. Okay. So for PTR, first time what it will do, it will point to the corresponding node. Second time, the same PTR will be updated to point to the next node that we will discuss now. So once the PTR is pointing to a particular node, then what we do, we apply the process to the info of PTR. Info of PTR. As I told you, info is nothing but our own data. It's nothing but our own data. So we apply process to info of PTR. Then now you see that the same PTR which we have initialized with the start, now it's updated with the link of PTR. Link of a PTR. So link of PTR means what? So this is the info part. This is the info part. I can just write it in different color. This is information part and this is the link part. This is the link part. So the link of PTR. So if this is the corresponding node where PTR is pointing, next the same PTR will be loaded or initialized with the or updated with the link of the PTR. Link of the PTR. So what it will do, now this will in turn it start pointing to this node. Okay. So set PTR is equal to link of PTR. Okay. So we do this. We do this continuously. How long? Until we reach the end of the list. End of the list. Finally, we can exit the program. That's how basically we do. Okay. So just to review the details, let's say, as I earlier told you, here the linked list is basically it is implemented in the form of it's basically linked list. Linked list is basically implemented in the form of a one-dimensional array, but two one-dimensional array we use. One is for using the list, and other one is for list means when say we can say information, and also we use another 1D for storing the link, that is a pointers to the next node on the list. Okay, so we use one array here. So as like an array, it will be having an index values. These are all index values. Index values of an array. So what array? The list array. Okay. Then there's another array that we have here. And also you can see that you will have the information. These are the informations. Whatever we have here in this part, it's going to be the information. And these are all index. Okay. And the next one is what? We have a link array. We have a link array. This is called link array. So the link array also will have index. Will also have an index. And what about this one? These details are not going to be information. Rather, it's going to be the address. It's going to be an address for the pointer. Okay. So now here, let us say the start. Start. What is the start now? The start is the pointer which points to the start of the list, starting node of the list. Okay, so which node it is being pointed now? Very good. It's 11th node that we are pointing to. Okay, what information that we get from 11th node is 2. After accessing the information, the linked node, it directs to the node number 11, directs to 16th node. That's to 16th node. In 16th node, what do you get? You get information 55. Okay. Then after getting information, where it leads to 16th node, 0th node. Got it. In 0th node, what do we have? We have 22 information. Then 22, after accessing 22, it leads to node number 3. In node number 3, we have 19. Then 19 is the information. Then it leads to 2. Leads to 2 here. So like that, what will happen? We can traverse the linked list. Now we can access the linked list in this form. Where is the end of the linked list? Which node is having the end of the linked list? Yes, that is node number 14 is having the end of the linked list. Node number 14. Once when you come to the phone, when you come to 14 and access the data, if you look for any of the link, it won't be there because that's the termination point. So this marks the end of the list. End of the list. Okay. Now let us discuss this simple algorithm. It is a simple program implemented with the help of an algorithm. Linked list traversing. Linked list traversing. So how do we do this? With the help of the algorithm only. Straightforwardly, the algorithm will help us. Algorithm will. So now let us say the same linked list what I've given there, it is reproduced here. Okay. So here we have the linked list. That the list we have, and also we have a link details. List is an array and link is also an array. So how do we represent it? So this simple implementation will help us to do it. So we have the header file here in line number 1, 2, and also now you can see that two arrays are two single dimensional array of size 20 is declared here. Of type what? Integer. Of type integer. So both will store an integer. And also there's a local variable called a start. It's a pointer again. It's a start. Okay. Then also we are going to use one function called a process that we will come to it. It's a prototype. It accepts one integer argument and returns nothing. So process is the function name. Now in the main program, we have one local variable called PTR. And we have to load the informations onto the corresponding array locations. What array is having the information? The list array is having the information. So as per the given details, node 0 is having information 22. That we will do it here. List of 0 is 22. Similarly, list of 7 is what? 29. List of 7 is 29. And also we have the list of 13, let's say. 13 is what? 50. So like that, what we'll do? We'll initialize every array locations. Some locations may be empty. You need not to worry about it. So that will be empty. Next, link array. How do we initialize the link array? So now here, link of 0. Link of 0 is having what address? 3. So we give it here 3. Similarly, link of 9. Got it. So that means the 9 node, it gets linked to the 18. So where is it? So here it is there. 9 having the value 18. And 14, you see that it's having a -1. It's very important here for us. Similarly, 18, it's loaded with the value 7. So like this, this is when a pen and a paper and a pencil method we have. So this is our concept. This is how the linked list. How do we translate to the computer? By using this array initialization. Then, so we start our linked list from here. Array traversing from here. So the start is initialized with the value 11. Okay. Then only the start will do just give the information from which node you are starting. Now the PTR is now initialized with the start. Now what is there in PTR? PTR will have the value 11. Okay. So what we'll do? We'll just say this is the initial list on the screen. Simply we'll put. Then what do we have to do? We need to take the information. We need to take the information. What information? That is on the list of PTR. List of what is there in PTR? That is 11. That is 11. What is that information? Total information, that is 2. 2. So print this number on the screen. So we will print it. It's a decimal number. We'll print it. And then what do we have? then this 11 is pointing to node number 16. Pointing to node number 16. How do we get to know? So that is given by the link of PTR. Link of PTR. So the 11 of or link of 11, it gives this 16. So now we update the PTR. Now we update the PTR with the link of PTR. So this is for one node, but we have to do it for every node. So how do we do it? We will put it into a loop, and the loop is checked with this condition whether we have reached -1 or not. If it is not -1, we can continue with the same process. That's that. Okay. Then, so that is the accessing. So we can just take the values and print it. As I told you, that's one part. We can just take the value and we can print it on the screen. Next. For the next, if you want to continue to do it, again we have to reinitialize, reset the PTR to the start. We do it. Now what are we going to do? We are just going to apply some process, an arithmetic process to the nodes to the information what is there in each node. Okay. So what do we do here? For that we have one function called a process. Now let's look at the process. Process just accepts one integer argument. It takes this argument, and this is basically an address. Okay, the list of P1. Its pointer is pointing to one place, and that content will be multiplied into 10. In this context, if you look into it, our start is having the value 11, and in that you have an information 2. So 2 into 10, you will get the value 20. That will be the value on the updated value on the list. So in the updated list, instead of 2, you will be having a 20. So that is called applying a process. So that we will do it. Then after doing it, again to update to the next node, to point to the next node in the one, we will use what? We'll update the pointer again with the help of the link of PTR. That will direct to the 16. So now PTR is updated with the value 16 over here. Okay. So now what I want to do, finally, I want to print the values on the screen. Whatever that value we got, I want to print it on the screen. So again, what do I do? So after applying the process, now I reset my PTR to the start value. So again, it will start from the 11 because of this initialization. It will start from 11. Then it will continue to traverse, and now it just does the printing operation. So it will implement the printf, and the list will be printed on the screen. But this time, every content is multiplied by 10 with the help of this process function. Fine. Okay. Now let us look into the program. So this is the program here. And if you look into this program, I'll just right away run the program, the same program only here. So when I run the program, it gives the initial list. The initial list itself we have obtained by traversing only. So the initial list as per the linked list is 2, 5, 255, 22, 19, 5, 50, 87, 79, 33, 99, 29, and 8. After applying some process during traversal, that is multiplying each information by 10, we get the details like 20, that is 2 is multiplied by 10, 55 is multiplied by 10, 550, 220, 190, 870, 990, and 80, and so on. So that is the traversing a linked list and also applying a process while traversing a linked list. Okay, thank you.